Good morning, Physics 20. I hope you guys are all having a lovely August day today. So, we're going to continue with our physics lessons. Today, we're going to be looking at two-dimensional vector problems. Now, I'm going to do two videos on this. The first one, which is today, we're going to be doing perpendicular problems. In the next video, we're going to be doing non-perpendicular problems. So I'm breaking it up into two sections because it's really essentially two very different topics which you must do practice problems at the end of each. Okay? So enjoy the meme. It's awesome. Our mascot vector. Okay? So the reason I chose this meme is because we are absolutely going to be working hardcore with vectors today. You need to know your vector terms. You need to know what is vector. You need to know what is scalar. And you need to know that when I am asking for a vector, I need direction and I need magnitude. All right? Okay. So, ladies and gentlemen, we're going to be starting with our 2D problems, and we are going to be looking at our perpendicular problems. Okay, please mind the I don't mind the sound of construction. My husband and my uncle are finishing the basement, so you're going to be hearing construction sounds throughout the next couple of videos. All right, so ladies and gentlemen, scale drawings, we didn't do a video on those, and we'll do them in class. If you missed that lesson for whatever COVID reason, don't worry about it. It's not going to be in a test, quiz, or assignment. Don't worry about it. Okay? So the thing about doing a scale diagram is they're time-consuming, and unless done absolutely perfectly, there's going to be mistakes. So we need to be able to solve vector problems with calculations because you're less likely to get mistakes there. Now, for 2D problems, there's going to be two sections, perpendicular and non-perpendicular. Today, we're doing this video, we're doing perpendicular problems. Now, first, these guys are going to be, for this step, for what we're doing right now, is for vectors that are perpendicular. Now, what is perpendicular? These two lines are perpendicular. Two lines that are at 90 degrees to each other. Okay? So, this vector and this vector, that is 90 degrees. These are perpendicular. You can use these steps with that. This vector and this vector are not perpendicular to each other. You cannot use these steps on this problem. Okay? So you need to really make sure that you check to see if your vectors are perpendicular to each other before you start your problems. Okay? Now I'll show you how to do that. So these are your steps. I want you to put a star beside this, and I want you to highlight these guys here. And maybe even put a sticky on your notes so that way you know if you have a step that is perpendicular vector problems, that this is where you come for your steps. So number one, you are going to draw your vectors tip to tail. That is super, super important. You are then going to get a right angle triangle. If you draw them tip to tail and they're not right angle, that means you may want to reassess to see if this is the right method for that question. Okay, you are going to use Pythagorean theorem to calculate the resultant. Okay, so remember, the resultant is essentially your net vector. Okay, so we'll talk, and the resultant is going to be your vector, the magnitude of your vector. That is going to be your hypotenuse, okay? And then you're going to use trig to solve for your angle to get your direction, okay? All right. So, ladies and gentlemen, we are going to work through this problem. We're going to take our time with it. When we are done this particular problem, I'm going to stop the video. You guys are going to do a bunch of practice problems until you're fully comfortable with this. If you need help or have questions with it, then you are going to make sure you find a way to ask me those questions. Okay? But it's August. It's COVID. I've got no idea what's happening. So, play by ear. Okay. So, let us begin. Okay. You are learning to drive a standard. Awesome driving stick. Love driving stick. You can get excellent acceleration out of those gears. So if you guys have ever learned to drive standard, the time in this is not actually abnormal. It takes forever to learn to drive stick. It's awesome. If you have an opportunity, learn to drive stick. It's great. Okay. The learning part isn't great. The being able to drive stick when you're done learning is great. Okay. So you're learning to drive standard. You drive 165 meters south, and then you turn 214 meters east before you decide you've had enough for one day. The learning excursion took you a total time of 2 hours. Yeah, that sounds about right. The first time I drove stick, I was limping around a parking lot for a long time. Okay. So, ladies and gentlemen, what is your total displacement? What is your average speed? Okay. We're going to start with A. Now, let's relook at these words. Displacement. Is that vector or scalar? That's a vector. So that means I need magnitude and I need direction. So because direction matters with A, you need to come in now and hone in on those directions. South. East. Ladies and gentlemen, we're now in 2 dimensions. We are no longer on 1 dimensions. I can't simply give a positive and a negative anymore. I'm going to draw these tip to tail. I know these are perpendicular because south, east. These 2 directions are 90 degrees from each other. You need to draw these tip to tail, and we will then show that how these are, we know they're perpendicular. There's 2 ways to draw them, and I will show you both ways, and it doesn't matter which way, you're going to get the right answer either way. I'll show you the math both ways. Okay, so first you go south, then you go east. Notice how I've drawn my arrows. My vector has going south, so I put an arrow at the end. That shows the direction in which I am going. My vector then goes east, arrow at the end, showing the direction I'm going. Now, ladies and gentlemen, I'm going to look at this. South, east. That is a 90-degree angle. This is perpendicular. I can use the steps above. I need to determine my resultant. So you see this dotted line that I'm drawing here. That is the resultant. That is going to be your displacement. The as the crow flies distance and direction from where you started to where you finish. Notice how I've got 2 arrows squidged in here. That is what I want. That is what is correct. If you draw like this blue line here as an arrow, so that way it comes in a box, no. That only counts when you're canceling out all vectors and there's no motion. Okay, so that blue arrow is wrong. Do not do that. Your resultant is going to be pointing where you're going. If you're starting here at X and you're finishing here at Y, your resultant must be pointing from X to Y because you're starting here and ending here. All right? Okay. So how you draw your vector is important. I know it's super picky, but it's vital. All right? Okay. I'm just going to pause this and turn off the fan. I'll be right back. All right, I'm back. So what our next step, ladies and gentlemen, is going to be, we're now going to use Pythagorean theorem in order to get the value of our displacement, so the magnitude. So, once again, units must be the same here. You must use the same units. So you drive 165 meters south, okay? And you are going to then drive 214 meters east. Well, look at that. We have your Pythagorean theorem, okay? So remember that Pythagorean theorem, a squared plus b squared equals c squared. Remember from the review video that we did that this is your hypotenuse. So I need to find the value of my hypotenuse. So I'm going to rearrange this. Okay. And I am going to put my numbers into the equation. Now remember, ladies and gentlemen, when you're putting this in your calculator, be careful. The a squared and the b squared need to be squared before you add, and then the adding takes place, and then the square rooting takes place. All right? Okay, square first, then add, then square root. As this square root, everything in there is in brackets. Okay? Okay. So, you are going to take your 214, square it, add your 165, square it, add them, square root the lot. And once you do all of that, you are going to get your value of 270.22 ... meters. Okay, not too shabby. So, ladies and gentlemen, then what we're going to do, we've done our first step, we have our magnitude. Now we are going to need to solve for our direction. Remember, I said vector. Displacement is vector. You must have a direction with this in order for you to get full points. Now, the direction is going to be based on where you start. We started at point X. That means my theta is going to be the one from where you start. Okay? Now, I have multiple different options to get theta. I want you to use tangent here. Why do I want you to use tangent and not sine or cosine? I want you to think about that for a sec. Think about it. Error. So remember how in the review video we did earlier, I mentioned multiplication of errors. So the multiplication of errors is where every single time you do a calculation, there's going to be some rounding involved, even with your calculators, and there's going to be mistakes. So always use the values that have the least amount of math done on them to reduce your mistakes. So I'm going to use tan because I would be using my opposite and my adjacent of theta. Those are the values given to me in the question. So they haven't had any math done on them. So they have the least amount of error associated with them. They have the measurement error associated with them. But they don't have the math error on top of the measurement error. So I am going to use tan. What also helps, ladies and gentlemen, is if you've made a mistake here, using tan isn't going to mess up your next answer. So, remembering from our review video that tan of theta is equal to opposite over adjacent. Okay? We are trying to find the value of theta, so that means you need to do tan -1 of your opposite over adjacent. Theta is going to equal tan -1. Your opposite of theta is 214. Divide that by adjacent of theta, which is 165. That's a 4. Okay. So, in your calculator, you are going to put in tan, so second tan will give you the tan -1, 214 divided by 165, close your bracket, and you're good to go. Make sure your calculator's in degrees. Okay, no radians, please. And then what's going to happen? You're going to get your value of 52.36 ... degrees. Okay, so you ask, ladies and gentlemen, what happens if I drew my triangle the other way? So I want to show you what would happen if this is the case. Because when you draw your vectors tip to tail, there are two correct ways to do this. Okay, so I can draw east and south. Okay, so if you draw your vector triangle like this, that's okay. As long as the vectors are tip to tail, it's fine. You're going to get the same answer, or an answer that means the same thing. So our hypotenuse is here. Well, the 214 meters east isn't going to change. And the 165 isn't going to change. So your value of your hypotenuse is going to be exactly the same. Completely identical. I'm going to draw this in blue here. You could, well, there's your 214, and there's your 165. I've made yourself a rectangle by taking this triangle and moving it up here. That line from corner to corner is exactly the same. So it's not going to matter for your magnitude. It does matter for your direction, though. It's going to change the reference of your direction. So we're going to have red theta and we're going to have blue theta. So if you are going to do your blue theta, you would have your tan -1, and which would then be of your 165 over your 214, because 165 is opposite to blue theta and 219 is adjacent to blue theta. So that would give you the value of blue theta. For blue theta, once you plunk that into your calculator, you're going to get 37.6 ... degrees. Okay. Well, how can both answers be right, you ask? The reference. Think back to the video we did on the introduction to 2D, the intro to 2D, how you can reference an angle in two different ways and still get the same value or same meaning. Well, that's what's going to happen here. If you drew your triangle to get red theta, your answer, one with sig digs, okay, everybody's got 3 sig digs, so your displacement is going to equal 270 meters. If you used red theta, you would get 52.4, rounding, degrees. Now let's look at our reference. Okay, we start at the nearest axis. Here's our nearest axis. And we are going to move from the south, and we are going to be moving towards the east. Okay, that means we are east of the south line. Okay, all right. Okay, if you used blue theta, well, your magnitude is going to be the same. We've already talked about that. Your angle is going to be different. Okay, you would have, I'm running out of space here. I'm just going to write this underneath. 37.6 degrees. Now look at the reference here for this triangle. Here's our nearest axis. Okay, we are starting at the east line, and to get to that line, we get to the south. It is south of the east line. So, ladies and gentlemen, your vector questions on your 2D vectors are going to have 2 correct answers. The magnitude isn't going to change. You have 2 correct angles. Okay? Now, I want you guys to try something. Because on a multiple choice test, you're only going to be given one. So let's say, hypothetically, you do your test and it's on an assignment. I don't care which one you write. I'm going to give it to you. If you give me either of these answers, you're going to get the full points, provided you show your work and you've got sig digs and units and all that good stuff. So what I want you to do is I want you to take your answer, your 52.36 ... I want you to then take that value and go 90 minus your 52.36 and hit enter. Look what you get. 37.6. So because, ladies and gentlemen, I mean, look here. I'm going to write this in green. Like, that's 90 degrees. So, and blue theta is there. So red theta plus blue theta is going to give you 90 degrees. So if you have done your question on a test, as lessons on hint on your unit test, you have one of these questions for a multiple choice question, assuming we're still doing tests because of COVID. Bear with me. Talk to me in class about tests. We will talk about it in September. It's August. I don't know what's happening. So you have, so on your test, lesson subtle hint, you have one of these in multiple choice. So because you do, if you do the question and you're like, oh my goodness, I swear I got it right, and your angle isn't in the answer, go 90 minus your answer, and chances are you'll see it. Okay, guys? Okay. So, ladies and gentlemen, that is A. Okay. Okay. Well, now we need to look at B. Don't worry, B is easier. For question B, okay, we have to look at average speed. Ladies and gentlemen, is speed a scalar or a vector quantity? Scalar. Because it's scalar, we use distance, not displacement. Do we care about direction? No, we do not care about direction. So, what this means, we need to get our distance total. Okay, so our total distance, and which is your 214 plus your 165. Okay, so I didn't do that one earlier. I did it on my calculator. So your total distance, ladies and gentlemen, is going to be 379 meters. Okay. Okay. And time, we'll look back in the question. What's our time? 2 hours. Okay. Well, we got an issue, guys. What is it and how do we solve it? Hours. Good. I couldn't trick you this time. Pun intended. We have to convert this. There are 3,600 seconds in 1 hour. Your hours cancel. And so, ladies and gentlemen, your time is going to be 7,200 seconds. Cool beans? Cool beans. So you've been asked to calculate your average speed. So your V average, whoopsie, let's make that a bit neater, is equal to your distance total over your time total. We've already calculated our distance total of 379 meters. Your time total is 7,200 seconds. You are going to plonk that into your equation. And once you put that in and you do your math, you are going to get 0.05263 ... Now, ladies and gentlemen, this is scalar. No direction. Okay, do not put a direction here, please. Okay, this is scalar. We don't want a direction. So, but we need sig digs. 3 sig digs okay, from earlier in the question. So 0.0526, because this 3 will round down. So we're good there. Your units are meters per second. And that, ladies and gentlemen, is your answer for B. Sounds good? Cool beans. All right, so ladies and gentlemen, I know this is a lot. I know this is tough. So what you're going to do, I'm going to stop the video here, and I'm going to make a second video for the next piece, because that's where it gets really tricky. I want you to do these questions. Sit down, pull out your book, do these questions in that workbook of yours, and do as many of them as it takes for you to become comfortable with this concept. Okay? When we go on to the next one, it's going to be harder. So, because it's going to be so much harder, you need to be comfortable with this before you go on to the next piece. Okay? Okay. So do your problems, enjoy, rock the physics, and ladies and gentlemen, how do I stop this? Arg! There we go. All right. So ladies and gentlemen, as always, no fires, injuries, or explosions. See you next time. Bye.